Hello and welcome to Math with Mrs. Becker. Today in pre-calculus, we are going to start section 4.3, where we use matrices to transform geometric figures. So this is kind of a cool concept. You can describe the position, the shape, and the size of a polygon on a coordinate plane by naming the ordered pairs. So remember, like if you have a triangle, you would have 3 vertices. Every vertice is a point that if you connect the lines, you would create that figure. Well, you can take ordered pairs and turn them into a matrix. So notice here is point A, -2, -1. Here is point B, 0, 3. Here is point C, 1, -2. Notice the x coordinate is always on the top, the y coordinate is always on the bottom. So you can always take ordered pairs and turn them into a matrix. Now a translation matrix, remember a translation is another name for slide. So we can take figures and we can slide them up, down, left, or right. If you are sliding something to the left or the right, that is the x. If you want to slide something to the right, you have a positive value on the x. If you want to slide something to the left, you have a negative value on the x-axis. If you want to slide up or down, that is the y-axis. If you are traveling upwards, that's the positive. If you are traveling downwards, that's the negative. So what you do to do a translation matrix is you are finding the sum. So you would take the matrix from the ordered pairs and add a matrix, again, that must be the same size, that would help you to slide that shape up, down, left, or right. So if you want to go to the right, you'd have a positive number all the way across the top because that's the x. If you'd want to go down, you need a negative number all the way across the bottom, okay? Let's go ahead and do a couple of these. So step 1, they are giving us a shape. We want to go ahead and graph that shape. So A is -2, 1. There's my original A point. B is 3, 2. So right 3, up 2. C is 0, -3, so stay at 0, go down 3. Here is the shape that we are working with. So that's step 1, go ahead and graph it. Now step 2, create a matrix of the ordered pairs. So A is -2, 1. B is 3, 2. C is 0, -3. Now I know I'm doing a slide, and they told us we must find a sum. Sum means that you're adding. So if I want to go 3 units to the left is the negative direction, and it's the x. So remember, the top is the x, the bottom is the y. So I need -3 all the way across, because that way I'm moving every single ordered pair to the left 3. If I want to go 4 units up, that's the y. 4 up is positive, so I would have a +4 all the way across the y. Now when we add those will be our new order pairs. -2 plus -3, that's -5. 3 plus -3, that's 0. 0 plus -3 is -3. 1 plus 4 is 5. 2 plus 4 is 6. -3 plus 4 is 1. So this is A prime, B prime, C prime. The prime means that it's the image. It's what you're looking for after the transformation. So if I go left 5 and up 1, 2, 3, 4, 5, that's A prime. That's a new location for A. 0, 6, that's B prime. C is -3, 1, that's C prime. Connect them. Notice it's the same shape, the same size. What happened is the original figure moved to the left and up. Okay, let's do another one. Here is the triangle. G is 2, 4. H is 3, 1. J is +1, -1. So here is our original triangle. Now you need to take those ordered pairs and turn them into a matrix. So G is 2, 4. H is 3, 1. J is 1, -1. If you notice you're sliding left, right, up, and down, that is going to be a sum. If I want to go 3 units to the right, that's the x-axis. The x coordinates are on the top. Going to the right is positive, so I would have a +3 all the way across the top. 1 unit down. That's the y-axis because y runs up and down. If I'm going down, that's a negative direction. So I would have a -1 that would apply to all of the y values. When I add those matrices together, those are my new ordered pairs. 2 plus 3 is 5. 3 plus 3 is 6. 1 plus 3 is 4. 4 plus -1 is 3. 1 plus a -1 is 0. -1 plus a -1 is a -2. These are your new ordered pairs. So this is G prime, H prime, J prime. So I go to the right 5, go up 1, 2, 3. Here is G prime. H, 6 and 0. J, 4 and -2. Graph your triangles. There's your transformation using matrices. Okay, the next idea, you can do a size change. If you are doing a size change, what that means is you're making the figure larger or smaller. When you do a size change, you are multiplying by the scalar. So remember, the scalar is one number that goes out front of a matrix, and what you do is you distribute that number, so you multiply it to everything. So let's go ahead and try some of those. If A is at 2, 3, right 2, up 3, there's point A. B is right 1, down 2. C is left 3, up 1. So there's triangle ABC. Now I make a matrix. A is 2, 3. B is 1, -2. C is -3, +1. You want to enlarge it. The reason why you're enlarging is because you're multiplying by a number that is bigger than 1. So I am multiplying by a factor of 2. So 2 is the scalar. That means I have to multiply every single number by 2, and those are my new ordered pairs. 2 times 2 is 4. 2 times 1 is 2. 2 times -3 is -6. 2 times 3 is 6. 2 times -2 is -4. 2 times 1 is 2. So this is A prime, B prime, C prime. So I go to the right 4, up 6. That's A prime. B, I go to the right 2, down 1, 2, 3, 4. That's B prime. C, left 6, up 2. That's C prime. When you connect them, notice you took the triangle and you enlarged it. It's a bigger size. Let's do one more of those, and that is it for today's notes. If I have triangle DEF, make sure you graph DEF right away. So D is right 2, up 3. E is right 5, up 1. F is left 2, down 7. So here is the triangle that we are going to change its size. We are enlarging it by a factor of 4/3. It's going to be bigger because 4/3 is greater than 1. So I go ahead and make a matrix. So it's 2 over 3, 5, 1, -2, -7. I'm multiplying by 4/3. So when I do this, when you multiply fractions, it's top times top, bottom times bottom. So 4 times 2 is 8. It would still be a 3 because technically 2 has a 1 on the bottom. 5 times 4 is 20, so it would be 20/3. This would be -8/3. 3 times 4 would be 12. 12 divided by 3, hey, that's a 4. That's good. 1 times 4/3 is 4/3. -7 times 4 is a -28/3. Now, I know since it's fractions, it might be hard to figure out where you graph it. So what I'm going to do now is go ahead and turn each fraction into a decimal. If I take 8 divided by 3, I get 2.6 repeating. 20 divided by 3 is 6.6 repeating. -8 divided by 3 is -2.6 repeating. This is a 4. 4 divided by 3, 1.3 repeating. -28 divided by 3, -9.3 repeating. Here is D prime, E prime, F prime. So those are your new ordered pairs. So I go to the right 2 and a little bit more and up 1, 2, 3, 4. That is my new D. If I go to the right 6, almost to the 7, up 1 and a little bit, there's my new E. If I go to the left, almost 3 and down, this is all the way down to 7, so we're way off the graph. That's the new F. Connect them, and you will see that the graph did get a little bit larger. So those are the 2 ideas for the day. Today is a book assignment, okay? So what you want to do, they are going to give you ordered pairs. Just like we did, you want to graph the original figure. Then create, they call it a pre-image matrix. That's where you make the matrix from the ordered pairs. Remember, the X value goes on the top, the Y value goes on the bottom. Use matrix operations. So you're either adding to slide things up, down, left, or right, multiplying to change the sign. You will create a new matrix, then graph the new one on the same grid. So you're doing the exact same thing, numbers 2 to 5, 10 to 11, and 18 to 20. I hope you enjoyed our time together today, and I'll talk to you soon. Bye.